This is lab 1 dealing with constant velocity. Here's a table of contents. I'll do an introduction followed by explanation of Newton's second law. I'll show a video of an object moving in tracker, explain this motion, given some various calculations for our model. We'll actually run the simulated model in GlowScript. We'll compare the two and then have a what-if scenario before the conclusion. Just a brief introduction. The purpose of this lab was to observe the motion of an object that was moving at the same speed in the same direction and compare these results to a simulated model of Newton's second law. And by the end, this law should be proved to be acceptable and can be applied to real-world scenarios. It was a simple setup. I used my iPhone X camera to film a tennis ball rolling along a flat surface. This clip was then put into Tracker to obtain the object's position and corresponding time. And then here's just a brief explanation of Newton's second law, which we get from the principle net force equals mass times acceleration. We get this new formula, which is final velocity equals initial velocity plus net force divided by mass times change in time. And since we are dealing with net force equal to 0 in this lab, it can be determined that the final velocity will equal the initial velocity, which allows us to use a constant velocity during the path of the ball. Further, we can use a simpler position update formula of final position equals initial position plus velocity times change in time. And this velocity, as I said before, will be the constant velocity. Here was just the basic rolling of the tennis ball along a flat surface, nothing special there. That's the original video. Here's put it into Tracker to get these various data points. And as we see, it's not perfect. That's just user error, me not pinpointing the middle of the ball perfectly in every frame. But regardless, it still gives a pretty close representation. And we got some results from Tracker. We obtained the velocity for the ball during its time of travel using the position update formula from earlier, which we obtained the velocity of 0.86710900047 meters per second. And we can use this velocity to create the simulated model in GlowScript by the same principle of constant velocity as said before. Here is the code from GlowScript to create this simulation. And there was only a couple of tweaks we had to make to it, just obviously the position vector and the velocity. That's the value we obtained in, via Tracker. And then obviously net force equals 0 and make sure it's less than the time interval given. And with those few changes, we run the program and get this nice linear constant position versus time graph. As we see here, constant velocity is shown and produced a lot of data points. And we'll just compare the two now. And obviously, as you can see from just looking at the data points, the GlowScript has a lot more data points than the Tracker. That's just because of the frames used in the code simulation, which are obviously more than the Tracker. And there's a little bit of a dip in the Tracker as we see here. The blue line is Tracker, the orange line is the code. That's, as I said before, user error, not pinpointing the ball, not rolling in a perfectly linear line. Nevertheless, they're both pretty close. We see this dip here, but we see that the model does support what we saw in Tracker. Now we'll do a little what-if scenario, which is an inverted motion of the tennis ball, which we flip the axis in Tracker to give an alternative graph, which is the opposite of the original ball's motion, and the code would need to be added to for the velocity. But the magnitude of the velocity in this place will remain the same. The only thing that changes is the direction of the velocity, as seen here. This is the inverted motion. This is our original motion. Yes. Now we'll just close it up with right here. This lab was supposed to study the constant motion of an object with a net force of 0 on it, resulting in constant velocity, which is supported by Newton's second law of motion. And while there may have been various external forces acting on this tennis ball, such as friction, airflow, imperfect structures, etc., the experiment allows us to test this law in the real world. And as said before, there was definitely some user error via Tracker, not rolling the ball perfectly straight. But nevertheless, this still, as we see again, take one last look at the graph, definitely supports this law, as the lines are very similar to each other. Yeah, that's it. Thank you for watching.